Good morning, students. Good morning. Good morning, students. Yesterday, I already explained one problem. So, what is that problem? A four identical hollow cylindrical columns of a steel supports a
Sir,
big
sir, sir,
structure
sir,
of
sir, sir,
mass
sir, sir.
50,000 kg. The inner and outer radius of each column are 30 centimeter and 60 centimeter. Right? Respectively. Assuming the load distribution to be uniform, calculate the compressional strain of each column. The Young's modulus of steel is given. Young's modulus for steel is given. What is that? 2 into 10 raised to 11 Pascal. Remember, students, nothing is there. So one mass is there. Okay, what is that heavy mass? That is 50,000 kg, they told. So we have to put this mass with four hollow, columns like this. Okay, like this. So in two dimensional, I can write in this way also. Okay, so like this. So remember, all are same height. It means this mass will be distributed, uniformly along each, column. You know that. But here, outer radius and inner radius is given. Then how to solve these problems? Remember, students, in this case, what will happens? So outer radius, inner radius is, we know, 30 centimeter. Outer radius means we can take it as RO. RI means inner radius. What is that? 60 centimeter. We can convert this in terms of meter. Why? Because here kg is there. Kg is a big unit. So 30 into 10 raised to minus 2, meter. So this is 60 into 10 raised to minus 2 meter. Is it okay? Now, once you know the radius, can we calculate area? Area of cross section of each column. What is that? Each column we can write in this way. A, which is equal to pi. Pi r square. This is the, but here 2 radii comes, so that's why outer radius minus, inner radius. So after this you will get, just simplify yourself. So you will get somewhat 85 meters square. Just simplify yourself. Just simplify. You know the value. A pi value is, you already know, pi value is nothing but 3.142. So small surface, small space is there. See, you have to write all these things. Yeah, someone, yeah, you are getting, yeah, correct, correct. Then what is total mass? Total mass, that is 50,000 kg, they already given in problem. Then tell me how much mass comes on each column. What to do that? What to do for that? How much mass comes? How much mass comes on each column? So therefore, mass supported by each column. How can I write this? Yes, anybody? Yes, good, good, correct, correct, exactly, Francis. So what is that? 50,000 divided by 4 columns are there, 1, 2, 3, 4. So that's why 4. So you will get this much, 11,500 kg, 11,500 kg, 11,500 kg, 11,500 kg, 11,500 kg. So uniformly that will be distributed. Now what I want here, okay, strain. So to calculate that, okay, so we know the formula. What is that formula? Young's modulus. Why? Because these are the columns. Columns means, okay, as we know Young's modulus we have to take. So what we have to write for that? So let me to write here only. Okay, see, Young's modulus is nothing but what? Stress. Longitudinal stress by longitudinal strain. Strain, I want, strain is nothing but what? Strain is nothing but stress divided by Young's modulus. Young's modulus value I know, but how to calculate stress? See, stress, how to calculate in this particular case stress? So this much of mass is there. Mass, okay, this is the total mass. Remember, total mass is this much. Then mass on each column is this much. So it means it is downward direction. So m into g, m we know 12,500. So 12,500, let me to write in this way. So F by A again. So F is nothing but m into g divided by A. What is m here? Stress, which is equal to, m is nothing but what? Mass. Mass is, mass of each column is, okay, all are m into g. You can take any one, okay. Okay, 12,500 into g value. Why? Because it is comes under gravity now, vertical direction. So that's why 9.8 divided by area. What is the area of this column? We already calculated area. What is that area of calculation? So just to see, I already rubbed that part. Okay, 85 meter square it is. Then what you will get? Stress. Stress is nothing but here, after solving this you will get some on 1.44 into 10 raised to 5. Okay, stress is there. So that's why Newton per meter square. This is our answer. Remember, this is our answer for stress. Now it is bit easy to solve. Remember, once we know stress value, can we calculate strain? Why? Because we know this value, right? 1.44 into 10 raised to 5 divided by y value. We already know what is that y value for steel rod. Why? Because these columns, okay, these columns which are made up of, okay, so these columns which consist of number of steel rods, okay, so that's why what is that? 2 into 10 raised to 11 you will get, isn't it? So then what is the value for this? 7.2 into 10 raised to minus 7. But strain is there, there is no any unit. Okay, I hope you understood, students. Everyone getting same thing? Yeah, Prithvi, correct. Everyone getting same thing? Yeah. Is it okay, students? Yeah. Okay, okay. Then one more I told, right? One more question I told, very important question. Okay, in NCERT exercise they given one more question. What is that question? Let me to write. Just verify your answers. Okay, just verify your answer. Those who not, okay, solve, just please try to understand the questions. Okay, see students, that question is a rigid bar, okay, of mass 50 kg, 15 kg is supported symmetrically by 3. So many of you don't have any books also, so that's why I am writing everything. Okay, don't worry. Okay, if you want any PDF format, okay, if you want PDF format of your NCERT book, just contact me. Okay, I will send you personally. Okay, if you want. Okay, See, 3 wires, each 2 meter long. These at each end are of copper, and middle one is iron. Okay, see here what they ask. Determine the ratio of determine the ratio of their determine the ratio of let me to join, few are waiting. Just mute your video, Ganesh. Yes, yes, fine. Okay, all came now. Yeah, what I written? Yeah, diameter of each is to have same tension. See, Young's modulus, they given in problem only. Just note all these points. Okay, Young's modulus of elasticity for copper and steel are the given 110 into 10 raised to 9 Newton per meter square and 190 into 10 raised to 9 Newton per meter square respectively. Yes. Students, just try to understand in this particular problem. Okay, just note this. Okay, how many of you done this? Just tell me. How many of you done this? Yesterday I gave this as a homework, right? How many of you done this? Not done? Students, not done? Okay, don't worry, don't worry. I will be there with you. Okay, always. Okay. If you have solution, if you getting answer means you just okay text me. Okay, yes, just try to understand. A rigid bar of mass 15 kg is supported symmetrically by 3 wires, each how much? 2 meter long. These at each end are copper and middle. So it means, let us just try to understand here. 3 wires are there. Okay, each are copper and middle one is iron. This is iron. Determine the ratio of their diameter. If each is to have the same tension, just try to understand, this is very important. Each is to have same tension. Okay, same tension means same tension will creates on each wire. Young's modulus of elasticity of copper as well as steel is given in this particular case. Okay, and length of each wire is given, that is 2 meter, 2 meter, 2 meter. And let us consider in this way, tension creates only when once we applied a force. Okay, this much of force will be there, then only tension will creates. Tension will creates always, it always upward direction, it is always towards its mean position. This is the mean position. Okay, tension, this is the tension, this is the one of the force. Okay, it is always okay move towards the mean position. This is the downward direction due to the weight. Okay, that is nothing but mg, as we know that. Yes, but in particular this problem, what they want, what they want, the ratio of their diameter. Remember what they given, just let me to write first, then we will see one by one. Okay, let me to write first solution for this. Here force acting on first wire, second wire, okay, third wire. So that will be same. In all wire, it will be same. It is just because of tension is remains same, they told. Then L1, L2 and L3, that is nothing but L is nothing but what? 2 meter, they told. And Young's modulus, they told Young's modulus for steel is 110 into 10 raised to 9 Newton per meter square. Also, Young's modulus for copper wire is 190 into 10 raised to 9 Newton per meter square. But I want here diameter. What is the relation? What is the relation between diameter and Young's modulus? Let's see that one by one. Okay. So we'll see. Just try to understand, students. We know one formula. What is that formula? Says Y, which is equal to F by A, Young's modulus formula, right? Delta L by L. Remember, again, F by A means what? Area. Area of this wire is nothing but pi r square. But you can write later in terms of what? Diameter also. Why? Because we know diameter is nothing but what? 2 times that of radius. But radius is nothing but what? D by 2. As we know this. Correct? Diameter is nothing but 2 times that of radius. Radius is nothing but half of the diameter. So once I, okay, apply this rule, okay, no need to write all these things. For your convenience only, I written everything. Okay. Just try to understand now. Now, F, okay, into L, okay, pi r square can be written as what? D square by 4. 4 will go to numerator, okay, into delta L. So now what is the formula now? 4 into, okay, F into L pi D square delta L. Just try to understand, students. Just try to understand. Okay. Just try to understand in this particular case, when force on each wire is same, then what will be the tension? Tension also same, but what will be the strain? What will be the strain comes here? How much strain comes on each wire? Can you tell me? When same amount of force is acting on each wire, what will be the strain? Anybody? Anybody? Can you tell me? Anybody? Yes, yes, good, good. Anirudh, good. What is that? Remember, students, clearly I mentioned here, when equal amount of force acting on all 3 wires, remember the strain amount also same. So strain will be, okay, same in each and, okay, every wire. Okay, you will get same amount of strain. It means we can say delta L1 is equal to delta L2, which is equal to delta L3 is nothing but what? Delta L. That is same. Can we write like this? Can we write like this? Yes. It means, remember, this is a constant value. F also same constant. L that is also same, 2 meter. Pi, it has its own value. This is a constant value. What is delta L? Delta L also same. So that's why, remember, students, from this equation we can relate Young's modulus is inversely proportional to, okay, 1 divided by D square. Okay, is it clear? But we want here D. So that's why D square is inversely proportional to 1 by Y. This is our relation. Remember, in competitive examination or in theory, so we want this. How it comes? We have to do all these things. Okay, I can't write directly here. How it comes? I written everything here. Okay, so from this relation, can you solve this? Can you solve this, students? Just please solve fast. Please solve the ratio I want. Okay, you know the relation now. What is that relation? Relation between, okay, Young's modulus and diameter I already written. Yes, just try to solve now. What is that? Young's modulus, okay, d square is inversely proportional to 1 by what? What is that? Y. This is the actual equation. Just calculate for copper as well as what? Iron. Just try to iron and copper. Just try to calculate for this. Take a ratio of these two. Yes, someone getting, yeah, good. Shilpa, just check once. Just check once. 1:1.25 you got. How it is? See once again. Any answer? Any other answers? Student, now time is okay. Only 3 to 4 minutes left. Okay. Once it log out means you just log in once again. Okay. Why? Because today onwards 1 hour class is there. You have to log in once again. Okay. You have to log in once again. Okay. Once it turn off, you have to log in once again. Okay. Why? Because today onwards 1 hour class. Okay. Yesterday that was 45 minutes. Okay, but in Zoom what will happens after 40 minutes? Okay, after 40 minutes, yeah, that is I am telling. In Zoom what will happens after 40 minutes it will turn off. Okay, so again you have to log in. That's it. Okay, yeah. Shilpa, how much you got? 1:? Just check once. Just check once. So let me to write my answer. So diameter for copper I am writing divided by diameter of iron, which is equal to, why? Because square is there here. You know this. Okay, I have to take square root both side. After taking square root both side, you will get Young's modulus of iron divided by Young's modulus of copper. You will get. Is it clear, students? Is it clear? Just a reciprocal. Okay, inversely proportional is there. So that's why, yeah, correct. So then you will get, see, I want ratio of this 190 into 10 raised to 9 divided by 110 into 10 raised to 9. You will get some ought 19 divided by 11. Okay, this one. So why? Because can I write the same thing in this way? 19 into 10 raised to 10 divided by 11 into 10 raised to 10. So this get cancels, only remains 11 by 19 by 11. So somewhat you will get 1.31. Is it clear? Shravan, how you got 9:7? Just check. Just check once. Everyone getting same thing or not? Just tell me. Is it okay? 1.25 you got, Shilpa. Just check once. Is it okay? Any other answer? Root of, okay, yeah, root of 1.72, right? That is 1.3 you will get. Maybe I am wrong somewhere. Okay, so but I got this answer. Is it clear, right? Is it correct? Root of 1.72 value is 1.31. Yes, good, good. Yes. Everyone getting? Anirudh, getting answer or not? Just tell me fast. Getting answer? Okay, good, good. Yeah. Okay, I will give you one more. Just do it fast. Okay, just do it fast. It is also NCRT problem, exercise problem, what they given in your textbook. Okay, just let me to solve this. Determine the volume contraction of a solid copper cube 10 centimeter on an edge when subjected to a hydraulic pressure of 7 into 10 raised to 6 Pascal. Then bulk modulus they given. Bulk modulus of copper they given, which is equal to 140 gigapascal. Yesterday I told you giga means how much. Okay, how to convert that. Okay, just try to understand the question. Okay, this is your NCRT problem. Yes, students, just try to solve this fast. Let me to admit. Okay. Yes. This is also very important problem. So which is asked in NCRT book. Okay, exercise problem. Yes. Just try it first. Okay, I want only one class to finish this chapter. Okay. Others, what sir? Will be, will it be? Yeah, this is we considering as a unit test. Okay, unit test. So be prepared. Okay, be prepared. You have enough time. Okay, you have enough time. Only two chapter. Only two chapter. You know, physical world is very easy chapter, and units and measurement, that is also very basic chapter. Okay, just go through once, just okay, revise once, you will get everything. Okay, don't worry. If you have any doubt, feel free to ask in any time. Okay, you can text me or you can call me. Okay, you can ask doubts, anything. Okay, I will be there. Okay, with you always. Okay, so don't worry students, so don't get tense. Okay, only two chapters are there. Okay, only 25 marks. Okay, 1 hour will be there. Okay, is it okay students? Yeah. uh, yeah, someone getting answer, I think. Good. What is that answer? What is that answer? Yes, Deepika, just check powers 10 raised to minus 8 you got. How how it is? Yeah. You converting, right? Yeah, correct. Yeah, correct. Yes, exactly. You converting, right? Yeah. Okay, then just let me to solve this. What they given? Determine the volume of contraction of a solid copper. So this is a okay, solid copper, okay, which is made up of, okay, copper cube 10 centimeter edge, okay, L will be how much? 10 centimeter, we can say. Now copper cube this is, right? Copper cube, right? Okay, like this. Okay, this is copper cube, length is given, L is nothing but here 10 centimeter they given. So let me to write 10 centimeter in terms of meter. Why? Because Pascal is there, so this is a big unit, so that's why 0.1 meter we have to write. Okay, then pressure, hydraulic pressure they given, what is that? 7 into 10 raised to 6 Pascal they given. Okay, then bulk modulus is nothing but what? B, we can write it as B. Okay, what is that? 140 gigapascal. It means we already know how to convert this gigapascal, okay, into Pascal. 140, 1 giga means 10 raised to 9 Pascal. Okay, then what I want, determine the volume contraction, change in volume I want. Okay, what is delta V I want? So we know bulk modulus is nothing but what? Bulk stress by bulk strain. Okay, so in other words, pressure they given, let me to write in this way. So FV PV divided by delta V, but I want a delta V. Delta V means what? Delta V means what? PV divided by V. But this is nothing but volume. Volume is nothing but length into breadth into height. So that is nothing but L into L into L. So L into L means L cube. So divided by B. B value, you know, just put the value, you will get the answer, students. Okay, just put the value, you will get the answer. Yes, good, Prithvi, correct, exactly. So finally, students, remember, P is, we know, 7 into 10 raised to 6 into L cube is nothing but 0.1 cube, you can write, divided by B value they given, what is that? 140 into 10 raised to 9. So finally you will get, okay, 5 into 10 raised to minus 8. So this is nothing but volume. So volume, so that's why meter cube. Okay, meter cube you will get. Is it clear? Yeah. Anirudh, just check what you written. 140 into 1.9 into 10 raised to 9. Anirudh, I didn't get what you written. Yeah, Prithvi, yes, correct. Good, just go ahead. Just tell me your answer, whether you're getting same thing or not. Just tell me. Yeah, Deepika, you are right. Yes, good, good, good. Yes, Anirudh, just tell me your answer. How much you are getting? Is it okay, students? Is it okay? Remember, I want one class to complete this chapter, okay? To complete this chapter. Okay. One more very important, you can expect this type of question, okay, in competitive also. Just let me to write in this way, okay? If possible, I will solve. Otherwise, you just take it as a homework, okay? Just try it, okay? Just try it, okay? Just write down. It looks tricky, but remember, once you understood the concept, so it bit easy, okay, to solve this problem. Remember, this is also given in exercise, additional problem this is, okay? A rod of length 1.05 meter having, I already solved enough problems, okay? So many problem I already solved. Okay, what they given in exercise, that will helps you to understand the concept. Okay, just practice once again. Okay, independently you have to solve. Okay, has its ends by two wires of steel. Let us consider this as a wire A, and aluminum. Let us consider this wire is wire B of equal lengths, has shown. I will draw that diagram later. Okay, has shown in figure. Let me to complete this first. The cross sectional area of wires A and B are, okay, A and B are 1 millimeter square and 2 millimeter square respectively. Okay, at what point along the rod should, okay, a mass M be suspended in order to, so one diagram I will draw later. Okay, okay, in order to produce equal stress and equal strain. This is 5 mark problem, remember, in both steel and aluminum wires. Okay, so this is the problem. Remember, this is asked in NCERT exercise problem. This is, okay, just go through if you have, okay, a test book, just go through this. Okay, given two quantity they given. Young's modulus for steel wire they given 2 into 10 raised to 11 Newton per meter square, and Young's modulus for aluminum also given. What is that? 7 into 10 raised to 10 they given. Okay, just to simplify carefully. Okay, just to simplify carefully, let me to draw that diagram. Diagram is like this. You can see this, right? Sorry, a diagram is somewhat like this. This is the rigid support. Okay, so from this they used one, okay, metallic rod like this. Okay, somewhere they put some mass. We don't know at what point we have to put this mass. Okay, just try to understand the question. 1.05 meter the length. Okay, length of the rod is given. Okay, and wire we have to consider, one is steel, another one is aluminum. Let us consider A and B, they given in problem itself. Okay, a rod of length is given having negligible mass, so its mass will be negligible. Okay, very thin rod we can say. Okay, supported has its end by two wires, steel and aluminum of equal lengths. This is also very important. So equal lengths will be there. Okay. So remember, this point also very important. The cross sectional area of A and B are given here. Cross sectional area for wire A as well as for B, they given. At what point along the rod should a mass be suspended in order to produce equal stress? I rubbed here. Equal stress and equal strain in both steel and aluminum wire. Whether we have to put this mass here, whether we have to put this mass here to get equal stress and strain, we have to check.